guys, I'm Pranamya and you're watching The Number Nexus. So if you're new to my channel, I'm Pranamya and I basically go over the one thing that no one wants to talk about after school, math. I know, it sounds boring, but trust me, we do so many fun things here. So today I'm going to be going over sort of the history or the origin of some math topics that we learn in our high school curriculum. Now I know, that sounds so boring. History and math combined together, those are like the two worst topics in school. It sounds like it's going to be so awful, but trust me, you're going to learn so many interesting facts and we're going to have so much fun.
So why is this even important? Why am I even doing this? Well, I recently just read a book called The Imperishable by Dr. Pascal Gumble, and he talks about how these important math topics that we've been learning on actually have been originated from India. And when you search up on Google, you're going to see that, let's say I searched up, okay, where did sine tables come from? They're going to say, oh, well, they came from the Middle East in the 16th century. But that's not true because Indian mathematicians were working on that centuries earlier. So that kind of brings us to the topic as of what math topics do we learn on day to day that Indians are not getting the credit for? Because I really just want to give credit where credit is due. Now, math gets a really bad rep because when we think about it in our day-to-day life, we just do the same 20 questions over and over again until it's kind of stuck in our brain and then boom, we got it. We don't understand the practical use of math. And I think it's so important because if we know what they used it for centuries earlier, then maybe we'll have a better idea of what they use for now and why we even use it. Because I know that when I was learning about, for example, geometry, I was so not interested in it. I did not understand why we needed to know about area or volume. I was like, yeah, okay, maybe if you're like an architect, but that's about it, because why else would I need to know this? But there's actually so many practical applications of it, and looking at how our ancestors used it helps us. So I'm going to talk about three main topics. A, geometry, which is pretty obvious. This is something that you go over all the time in math. B, sine tables. And C, the Gregory-Lebin series for pi. And we're going to learn about how these are actually not as boring as they seem and how they actually have strong roots in Vedic principles.
So first of all, geometry. Geometry is probably my least favorite math topic because in the beginning I thought it was just so boring. Now, often overshadowed, Hindu geometry has actually made so many significant contributions, particularly through the Soba Sutras. Soba Sutras were ancient texts which provided the foundational geometric knowledge. In fact, the terms Soba and Raju often referred to the strings and ropes used for measurements, but now we kind of use them to encompass the science of measurement itself. Now, why did ancient mathematicians even need to know geometry? Well, here's the interesting thing. This foundational geometric knowledge was actually used to construct beautiful altars for Vedic rituals, which is actually so interesting. These beautiful, amazing, stunning temples that we see today in India actually were made through math, which is so interesting. When I think of math, when I think of buildings made through math, I'm thinking about the regular word problem that I get, like person A has this big of a garden, what is the area? But no, now that I can think about it in the context of, oh, that beautiful temple that you saw in Delhi, yeah, they constructed that using geometry. Now, the Soba Sutras had these basic geometric principles that we use to this day, like the calculation of areas for various shapes and the application, which is now known as the Pythagorean theorem, something that we use every single day in math class. In summary, Hindu geometry, as documented in the Soba Sutras and expanded later by mathematicians, laid crucial groundwork in both 2D and 3D objects, influencing mathematical thought and practices significantly. Next, I also want to talk about sine tables. Now, when I talk about sine tables, I'm going to specifically focus on Aryabhat's sine tables. Aryabhat was this amazing pioneering mathematician and astronomer who made significant contributions to trigonometry through his creation of sine tables. Now, when we think about sine tables, we often think about sine differences, the algorithm for calculations, and then the verse for sine differences. And it doesn't really make sense to us. I don't think most of my friends understand why we even use sine tables. So I thought it was so interesting to go back and see what Aryabhat was using it for. Well, he presents this very long table of sine values for 24 equally spaced angles between 0 and 90 degrees. This table was revolutionary, and it still is, because not only was it used for its precision, but also for the innovative approach that Aryabhatta employed. When you go to the dentist, when you go to the doctor, they are often going to be using similar technologies that use that math to precisely lay down whatever they need to. This was such an innovative approach, and it showed such accuracy and utility that we still use it centuries later. The last topic I'm going to be talking about is the Gregory Lebin's series for pi, or the infinite series for pi. Now, these were originally formulated by the Indian mathematician Madhava of Sangamagrama around the 14th century. This series, which later became known as the Gregory Lebin series, expresses pi as an infinite series. So the formula would just be pi equals 4, open parentheses, 1 minus 1/3 plus 1/5 minus 1/7 plus, and so on, close parentheses. This is something that we use all the time in math, specifically geometry. Now, Madhava's contributions were recognized by other scholars of the Kerala School of Mathematics, like Shankara Vadiyar and Nilakantha, which attributed the series to him. This work represents the first known infinite series expression for pi, developed centuries before its rediscovery in Europe by James Gregory in 1668. Furthermore, this kind of highlights how the Kerala mathematicians' advanced mathematical techniques surfaced in Europe 3 centuries later, showcasing the sophisticated system of education and knowledge transmission in ancient or medieval India. Now, when we think about today, we kind of think, okay, well, as Gen Z, we know that we're probably the most technologically advanced generation out there. I mean, as generations grow, we gain more and more knowledge. However, it's interesting to think about how centuries ago there were people that were learning and the exact same things we are and discovering the exact same things we are using this foundation that we've had for almost a millennia now. Well, that's it for today at the Number Nexus. I'll catch you next week at the same time. Bye!